Welcome to this lesson on the unit of work pattern. It sits in the architectural tier of design patterns, and its job is deceptively simple. Keep a running list of everything your code changed during a business operation, then push all of those changes to the database in one clean, atomic step. Imagine you are processing an order. You update inventory, create an invoice, and debit the customer's balance, 3 separate repository calls. If the server crashes after the first 2, your database is now inconsistent. You also have no central place that knows which objects were touched, so you either save everything, wasting round trips, or you hand-roll change tracking in every service method, which is fragile and repetitive. Think about grocery shopping. You would never walk up to the register after every single item you picked off the shelf. Instead, you accumulate everything in your cart and pay once at the end. That single checkout moment is atomic. Either everything goes through or nothing does. The unit of work works exactly the same way. Accumulate changes in memory, then commit once. The unit of work pattern maintains 3 internal lists: objects that are new and need to be inserted, objects that are dirty, meaning they were loaded and then modified, and objects that are marked for deletion. Repositories use the unit of work to register changes rather than executing SQL themselves. When business logic is done, a single call to commit sends everything to the database inside one transaction, guaranteeing atomicity. Start at the top. The entity interface just says, every tracked object has a numeric ID. The unit of work class holds 3 private arrays: new entities, dirty entities, and deleted entities, one for each kind of change. The 3 register methods simply push an entity into the right list. No database call happens yet. The commit method is where the real work occurs. It processes all 3 lists, inserts, updates, deletes, and in a real implementation, you would wrap those calls in a database transaction. After committing, it clears all 3 arrays, so the unit of work is ready for the next operation. The order repository receives the unit of work through its constructor, that is dependency injection, and its add, update, and remove methods just delegate to the corresponding register call. Finally, the client creates one unit of work, wires it into the repository, performs 2 operations, and calls commit once. One flush, one transaction. During a business operation, your service code freely creates, modifies, and removes entities. Every repository call is essentially free at this stage. It just appends to a list. When you finally call commit, the unit of work iterates those lists, generates the SQL, and executes everything inside a single database transaction. This is also the moment to check optimistic locks and detect conflicts. The key consequence is a clean separation. Your domain logic never worries about when or how changes reach the database. Reach for unit of work when a single user action touches multiple entities, and all of those changes must succeed or fail together. It is also the right home for optimistic concurrency checks. On the other hand, if your ORM already ships a built-in session or context, like Entity Framework's DB Context or TypeORM's Entity Manager, you are already getting unit of work for free, and adding your own layer is redundant. For simple single entity CARUD or read-heavy workloads, the extra bookkeeping is all cost and no benefit. To recap, the unit of work pattern acts as an in-memory ledger for your business transaction. It registers every new, changed, or deleted entity as your domain logic runs, then commits them all atomically in a single database round trip. It pairs beautifully with the repository pattern, and it gives you one clean place to enforce concurrency rules. Just check your ORM first, you may already have one built in.